Okay, so in this video, I'm going to show you how to find the orthocenter of a triangle using the coordinates of the vertexes algebraically. So in order to do this, you need to remember what an orthocenter is. An orthocenter is a point of concurrency where the altitudes intersect. All three altitudes will intersect at the orthocenter. So in order to understand that, you have to know what an altitude is. An altitude is a line of concurrency that goes from the vertex to the opposite side and will intersect perpendicularly. Now, sometimes that side needs to be extended. If it's an obtuse triangle, you have to kind of extend the side so that the altitude will hit perpendicularly. All right? So altitudes, again, the keys are they are perpendicular to the side opposite of the vertex. So you're going to use the vertex, you're going to use the slope of the opposite side to be able to find this. So let's start off with, and again, there are three sides, three altitudes. You only need to find two. All three will go through the orthocenter, but you only need to find two of them. The third one you could use as a way to check to make sure it's the same. But if you do your math right, you should be in good shape. So let's start off. I'm going to do AB. So let's find the slope of AB. So if we're doing the slope of AB, that is going to be equal to 2 minus 5 over negative 3 minus 4. And so that gives us a slope of negative 3 over negative 7, which is really, in fact, 3 over 7. And then we could also find the slope of BC, and that's going to give me 5 minus negative 2 over 4 minus 7, and that gets me 7 over negative 3, or negative 7/3. Okay, so remember, those are the slopes of the sides. Our altitudes need to be perpendicular. So we're just going to flip that into a negative 7 over 3 and a positive 3 over 7. All right? So now that we have the slope of the lines, the slope of the altitudes is really what we're working with here. We have the slope of the altitude. We need a point that each altitude will go through. So the altitude to AB will go through point C. So I have that as 7, negative 2. So we'll use that with the perpendicular slope to write the equation y plus 2 equals negative 7/3 x minus 7. And let's go ahead and talk about the altitude of BC will go through vertex A. Vertex A is negative 3, 2. And using the perpendicular slope of 3/7, we can write y minus 2 equals negative 7 over 3 times x minus negative 3. You see I simplified that. So let's go ahead and simplify these equations. And I messed up my slope there. So let's just erase that, and we'll come back and rewrite it incorrectly. So y minus 2 equals 3 over 7 x. There we go. Now we have the correct equation. So now we can simplify. I'm going to rewrite the first one, y plus 2 equals negative 7 over 3x plus 49 over 3. So that means I'm going to subtract 6/3 from both sides. And that's going to get me to y equals negative 7 over 3 plus 43 over 3. And then on my other equation, let's go ahead and do y minus 2 equals 3 over 7 x plus 9 over 7, which means I'm going to add 14 over 7 to both sides. And I end up with y equal to 3 over 7 x plus 23 over 7. So now that we have our two equations set up properly, it's just a matter of doing a system, all right? So the system of equations is going to be equal to, we'll just set both equations equal to each other, all right? And let's just do that. We'll do negative 7 over 3 x, which I missed it in my equation up here, plus 43 over 3 equals 3 over 7 x plus 23 over 7. Okay, so what I like to do when I have fractions like this is just go ahead and multiply by my denominators to get rid of that fraction. So I'm going to multiply everything times 3. So since I get rid of everything times 3, I get negative 7x plus 43 equals 9x over 7 plus 9 times, so that'd be 69 over 7. And then I'm going to multiply everything times 7, and I end up with negative 49x plus, so 43 times 7, if you can't do that in your head, no worries, it's 301. And then we get over to the other side, and that makes it nice and easy, 9x plus 69. Okay, so now it's just a matter of simplifying this and solving it. So add 49 to both sides, 49x, and then let's get rid of that 69 by moving it over. All right, so somehow I have an eraser. So let's just do minus 69. That ends up getting you 232 equal to 58x. And when you do that math, you get x equals 4. So now that I have an x value, I can plug it back into one of my equations. Let's just go ahead and do y equals 3 times 4 over 7 plus 23 over 7. So that gives me 12 over 7 plus 23 over 7, which is 35 over 7, which is 5. So my x value is 4, my y value is 5, and that is the orthocenter. That is the coordinates of the orthocenter using coordinate geometry. So again, you're not going to be able to completely avoid these messy equations, but hopefully you can see how by multiplying by the denominators, you get something that's a little easier to work with, and then you just got to kind of plug it in. So you cannot avoid fractions, but take your time, make sure you have lots of space to work this out, and then you should be good to go. All right? Let me know if you have any questions. I hope this was helpful for you.